Hey everyone, we're going to be talking about images today. Now there are two types of images, real images and virtual images. You may have heard those words thrown around a little bit in the last couple days, so we're going to talk about them today. First, we have real images. Real images are when the light rays converge. So you have all these light rays and they converge to a single point. That's a sign of a real image. Also, real images can be projected onto a surface, like a movie screen. Virtual images, however, when the light rays diverge. So they don't come to a single point, they go away from each other, they diverge away from each other. And virtual images cannot be projected onto a screen. So this doesn't really explain a whole lot. Now, a wise man once said, a demo is worth 1,000 words. So let's do a demo. This is a pretty easy one that you can do at home. Here's what you're going to need. You need a flashlight. And the flashlight, preferably you can adjust the beam of light to get a pretty narrow beam of light. That works best. You need a makeup mirror, and that makeup mirror needs to be able to magnify the image. Now we know that's really a concave mirror after we talked about that. You need an object. So in this case, I've got Monica, as one of my daughters named her. She's just a fake head that we use to practice braiding. And then you need a screen. It can be an actual projector screen, it can be a light colored wall, or it can just be a sheet of paper. It doesn't matter. Okay, so you need the room pretty dark because you don't want the ambient light hitting Monica. So I've got the bright flashlight on Monica's face, and use whatever object you have around the house, brother, sister. But I'm going to face the concave mirror towards it. So the light's going to reflect off her face, go into the concave mirror, and it should converge, and it should be able to produce a real image. So let's try that. Okay, right there. All right, I don't know how this is coming through on video, but I can see her eyebrows, her eyes, her nose, her lips, everything is pretty clear here. So right now I've got the mirror the perfect distance from the screen, so that is the image distance. That's right where all the light rays are converging. If I bring the mirror closer, now the light rays are converging beyond the screen. And at some point, like now, I should be within that focal point. So we're getting a virtual image. So this would be the makeup mirror. You see a big image of yourself in the makeup mirror. This is what Monica's seeing right now, but you cannot project it onto a screen. I'll go back here. We're in focus again. So we're right at the right image distance. And then I'll back up farther. And now the light rays are converging before they hit the screen, so it's out of focus again. Now, one more thing I want to do, I'm going to flip the mirror over. So this is the flat mirror side, so this does not magnify. And you'll see that we can never get an image projected onto the screen, no matter how close or how far away I get. We don't get an image because a flat mirror always produces a virtual image. So there you go, pretty cool demo. Try it at home, explain it to your family. One of the ways you can do the same demo with a concave mirror is you want to be in a dark area. So I've made the house as dark as I can, but you want it bright outside. So I'm just going to have the screen, the cardboard, up against that, and then I've got the mirror facing it, and I'm going to bring it in. So there we can see the neighbor's house. It's upside down. That's a real image. So real images are always upside down. Just like with Monica, we see it fairly in focus, but you can see it pretty clearly that it is upside down, and that is a real image. Those demos were pretty cool, weren't they? Those are a couple of quick, easy demos that you can do at home if you have a makeup mirror. That's really all you need. I'm sure you have the rest of it. So anyway, I like to do demos in class, and I was a little concerned about doing demos in e-learning, but that was really easy to put that one together, and it worked really well. So I hope you enjoyed that. Now, that gave you an idea, or you could actually see the real images like that. So now let's look at some ray diagrams to get a better understanding of why that happens. This is a really cool website called SimBucket. They've got a lot of really interesting simulations in that. I'll put a link to this in the description of the video. Here we've got a candle. This is our object, and then we've got the concave mirror. So we talked about how to draw these light rays. We know light rays are coming off in every direction. We only care about the one that's going parallel to the axis, and we know it's going to reflect through that focal point. And then we care about the other one that is, or another one that is going through the focal point and then reflecting back parallel to the axis. So we see those two reflected rays intersect. They converge. Converging, that tells it it's going to be a real image. And notice it's upside down. Just like in the demos, we saw the real images were upside down. That is a characteristic of a real image. All real images are upside down like that, or inverted from the object. Now we can move the object closer and farther away. So we can put it right here. When you're 2 times the focal length, that's where you're going to get an image at that same location, same size, just inverted. And then we can come in closer like this. So we did this in the video with Monica, the mannequin. And then once we get the object close to the focal point, we start to lose that image. All right. And then once we get it inside the focal point, all of a sudden, boom, it flips to the other side. So now we can see the light rays, the 2 light rays we're talking about, parallel, and then the focal point one, they're actually reflecting and they diverge. They're going away from each other. So that tells us virtual image. Notice the virtual image is right side up. That's characteristic of virtual images. All virtual images are going to be right side up. All real images upside down. And you see that image is a lot bigger than the object. This is the makeup mirror situation. So now, why we didn't see that in the video is, remember, we were looking away from the mirror. It's like we're standing here with our back to the mirror and looking to the left. And then we're looking at the projection over here. So we didn't see that nice clear image because these rays diverged. Monica was looking towards the mirror, so she saw a nice enlarged image of her head. If we go back out here with the real image, this is where we saw the real image. So again, our backs are towards the mirror and we're looking this direction, but we have the screen right here. And that's where those rays converge. And that's why we saw that nice real image like that. So real image upside down, virtual image right side up. Now we can look at a convex mirror as well. So I'm going to go to the other side. So now we've got a convex mirror, and you can see no matter how close or far we are, convex mirrors do the same thing all the time. They diverge the light rays. So the reflected rays are diverging. Boom, we know it's a virtual image. We see the image is upright. That's another indication that it's a virtual image. Another thing to notice is the virtual images are on the other side of the mirror. Now, mirrors reflect light, so in my head, I would expect any image to be on the same side of the mirror, but virtual images are on the other side of the mirror, and that's kind of why we call them virtual, is they're not actually there. You can walk around behind this mirror and you're not going to see an image there because the mirror blocks or reflects all that light. Now we can flip to the concave mirror again, and we'll see that again, virtual image on the other side of the mirror, and real image is on the same side of the mirror. So all those indicate real versus virtual images. Now going back to the plane mirror that we looked at before, we should be able to quickly determine whether this is a real or a virtual image. So on the left side, this is the object, and then this is the image. So a few things I noticed right away is the image is on the other side of the mirror. It's virtual. The image is upright. It's virtual. The reflected rays, which it's hard to see here because we're looking at 2 different points, the feet and the head. But if we look at the head, one ray comes in here, it reflects this way. You could have another ray going straight into the mirror, perpendicular to the mirror, it's going to reflect straight back. So if you imagine that ray and this one, they diverge. So those 3 things, upright image, image on the other side of the mirror, diverging rays, all indicate this is a virtual image. As we showed in the demo, you cannot project this onto a screen. All right, let's wrap this up. So real images, they are when the reflected rays converge to a single point. You know it's a real image if you see that. The image can be projected onto a screen. If you see an image projected onto a screen, you know it's real. Image is always inverted. Real image is always on the same side of the mirror as the object. And the real image, it may be larger or smaller than the object, depending on where that object is located. Real images are formed by concave mirrors when the object is outside of the focal point. Convex mirrors never are able to form real images. Virtual images, these are when the reflected rays diverge. You know it's virtual. If the image cannot be projected onto a screen, it's virtual. If the image is upright, you know it's virtual. The image is always on the opposite side of the mirror as the object, where you wouldn't expect an image to be. The image may be larger or smaller than the object. If it's a concave mirror and the object is inside the focal point, you get a larger image. That's the makeup mirror. And convex mirrors, they always do one thing only. It's always a virtual image on a convex mirror, and you always get a smaller upright image there. So that's it for real and virtual images. We're going to revisit this when we talk about lenses. Shoot me an email if you have any questions.